the Gauss's law and electric flux. So,
Okay.
I have just combined this with that the previous lecture. So let's see the electric flux.
Electric flux.
Please read if you can see. So read.
Electric flux. The number of electric field lines crossing a given area kept normal to the electric field lines is called electric flux. It is usually denoted by the Greek letter and its unit is
See,
Newton meter.
this is actually the phi e. Phi is the
Phi E.
word alphabet. So a Greek letter phi
Phi E. E.
e for the electric, and
Electric flux.
unit is Newton meter square
Newton meter
per
square per
coulomb.
coulombs.
Electric flux is a scalar
Flux
quantity,
is a quantity and it can be positive or negative.
negative. So these are the, we can say, these 3 points: the number of electric field lines increasing a given area kept normal to the electric field line is called electric flux. It is
Flux.
usually denoted by Greek, and electric flux is a scalar quantity. So
Quantity.
after having said this, now let's see the next is.
Electric field of a point charge.
So there is a point charge rightly placed at the center. So
Yes.
all dimensions, the electric lines, feed lines are coming out. So we have the source. Now A, B are actually the perpendicular areas. When these
Yes.
perpendicular areas putting together across in the line of these lines, electric field lines, so we can get the effect of all these. But this is now in the all dimensional. Q is the center of this field, and the electric field lines are spreading in each and every direction. So this is
Direction.
the, what we can say, the pictorial view of this statement. What we have seen in the first,
Yes.
the number of electric field lines crossing a given area,
Crossing a given area
normal to
kept
the
normal
electric
to
field.
the
So
electric field
these
line.
two blue shaded areas are kept normal in the
Yes.
lines of electric field. Now let's see the next one is, please read this.
Consider two small rectangular area elements placed normal to the field at regions A and B.
Yes.
Even though these elements have the same area, the
Let me.
number of
Okay, please stop.
okay.
So consider two small rectangular area elements placed normal to the field at regions A and B. So this was the what we are saying over there. So
Yes.
here you can see that this is the area A and this is area B. So that's why we are saying consider two small rectangular area elements placed normal to the field at regions A and B. Next point, please read this. Even though,
Yes. Even though these elements have the same area, even though the elements have the same area, the number of electric field lines crossing the element in region A is more than that crossing the element in region B.
yes. Now
Therefore,
let's
the electric flux in
hold
A
hold
is more
for a
than
while.
B.
Hold for a while.
Okay.
Let me explain this one. So what, even these elements have the same area as we have seen in the
Yes.
diagram. The number of electric field lines crossing the element in region A is more than
A.
the crossing
Crossing
that
the
crosses
element in
the
region.
elements in region B. Now let's see. Yeah, yes. Can you see
Electric
this?
field of a point charge. Yes.
So it is
Yes.
real
A
that
is more.
more lines are passing through this area, and this is
Yes.
away from the source of
Less. So less lines are
number of,
relatively less.
yes. So what we can say, the intensity of the electric field is greater near the
Greater
source,
in
near
source.
source, and whenever we are moving away, so we are getting the less effect. At some point, there may not be even a single line.
Any effect
That is the out of the region, out of the
out of
electric field,
yes.
out of the electric field. So this was a second. Third one is therefore.
Therefore, the electric field in region A is more than in region B.
Yes, electric flux in region A
Flux,
is more than
flux in
that.
region
So electric flux is what you
A,
can say directly proportional to the
more in region A than
distance
B.
between the source and the placed area. So
Is
near
less.
area, the number
Near
is
electric flux increases.
greater and away
Yes,
smaller. Next one
smaller.
is
The electric field strength for a point charge decreases as the distance increases. Then, for a point charge, electric flux also decreases as the distance increases.
so what we have seen over there in the picture and what we were talking about that when
As the distance
distance is
you are
increasing,
further away from the source, the point
flux
charge decreases, or the strength
is
of the point charge.
inversely proportional to the distance.
Yes,
The strength, the electric field strength is inversely proportional to the distance. And the distance is increasing, the electric field strength is decreasing. Decrease the distance,
decreases.
you will get the increase in electric field strength. Let's see the
Yes.
next one is
Electric flux for uniform electric field. Consider a uniform electric field in a region of space. Let us choose an area A normal to the electric field lines. The electric flux for this case is phi E equals to electric flux of
EA.
area A, EA.
EA. E is the electric
E
flux, the intensity of
flux and
A is the area.
A is area.
The area of that perpendicular surface placing
Yes.
normally to the electric field lines.
Field lines.
Next, suppose
Suppose suppose the same area A is kept parallel to the uniform electric field. Then no electric field lines pierce through the area A. The electric flux for this case is zero. Phi E is equals to zero.
how can you explain this?
No lines. This is when you go farther away from the source of
Further
the
away,
point charge.
no, further away. Position is same, but you are just putting the plates parallel to the lines. So lines are passing
Yes.
not through
Oh
the.
yes, we put it the other way, so then less lines pass because the area from
So,
the more space.
so very thin plates are placed
Yes,
not perpendicular,
and
parallel.
yes,
They are not penetrating. They are passing from above or below. So lines
yes,
are not penetrating. So that's why
yeah,
he is saying that suppose the same area is kept parallel to the
to the lines,
electric field, not perpendicular, parallel.
parallel. Then the lines just are in the same
The
direction as the
lines
plate,
pierce through
so
the
the
area A. The electric
yes,
flux for this case is
yes
zero.
is
So
zero.
epsilon E is zero. No lines are passing through because the plates are parallel. So these are parallel to the lines. And when the
Lines.
lines are parallel, they are not crossing each
They
other.
don't cross each other.
Yes, just like the track of railway train. The
Yes,
two what we can say the two lines are
they
parallel.
don't. They don't meet.
Bank of the river, two banks of the river. So they
Yes,
are
they
not
don't meet.
crossing each other because they are the parallel. And we have seen the parallel lines, they will never intersect each other.
Never intersect
When
each
the
other.
lines and the plates are parallel, so there is no question of intersecting or no question of crossing them. So that's why it's very simple. The electric flux to the parallel points, parallel to the electric field lines is zero. So epsilon E, phi E is zero.
Zero.
Okay, I think it's very much clear now.
Yes.
Next,
If the area is inclined at the angle theta with the field, then the component of the electric field perpendicular to the area alone contributes to the electric flux. The electric field component parallel to the surface area will not contribute to the electric flux. Phi
yes.
is equals to electric field cos theta times into area.
So,
For
so
this case, the electric flux would be this.
yes. Now let me explain this. So when you are just putting plates or the area, rectangular area at some angular position, so that is still
Yes.
not parallel, not perpendicular, tilted to an
Not
angle
perpendicular.
theta. Now in this case, the only dominant components of that tilting angle is cos, because sine is,
Yes,
that is once again parallel. So that is
parallel.
coming to the count. So we are just taking the, we will have to resolve this vector, this angle, into two components, that is the vertical and the parallel,
Horizontal.
horizontal,
Parallel.
horizontal and perpendicular. So
Vertical.
we get the only one part, the only one component, that is cosine of A, cosine of theta. Theta is the angle which is
Yes.
made with the line of the action, and A is the
Correct.
area of that, what we can say,
Uh,
that
The
rectangular
region.
region. For this case, the electric flux is E cos E is the intensity of the electric flux.
Intensity of electric flux.
Further,
Further, theta is also the angle between electric field and the direction normal to the area. Hence, in general, for uniform electric field, the electric flux is equals to electric field into area, the E into area cos theta.
yes. So
A is the area vector,
yes, A
and then
vector
A is equals to
and
A vector is
N,
equals to
N is a
N.
unit.
But
Its
yes,
magnitude is simply
it's simply A, and the direction is along the unit A vector and perpendicular to the area.
perpendicular to the
Theta,
area. So
yes,
once again, we are coming to the point that all that is when we are resolving this angle. So we are getting
yes,
the total fluxes which is perpendicular to that area, which is coming to account. So we can say if theta is 0, so
yes,
there is that is the perpendicular, no tilting of that. So EA,
yes,
no theta, because
yes,
cos
yes.
90 is 0. So in the other
Zero.
way, if theta is 90, cos 0 is 1, sorry, cos 0 is 1. Another way, if the theta is 90, so phi E dot A is 0, because now
Zero.
the cos 90 is 0. So we will
Zero.
have to take the two values. Theta is 0. So cos theta, when we are putting in the equation above, so cos 0 is always 1. But cos 90, when theta is
1.
90, cos 90 is 0.
Yes.
So that's why it is
0.
0. Cos
0.
90 is 0, cos 0 is 1. So this is all about the angles. When you are just putting it perpendicular, the angle will become 90 degree, and when you are putting it parallel, so it is 0. So in this case you will get the maximum and the minimum value depending upon the theta. Now let's see this. E is
Okay.
the electric flux lines passing through. Now look at this figure. Can you see this?
Yes, I can see this.
Yes. For the red lines
Right.
coming for the electric fields lines, and n is the, what we can say, the a perpendicular area, direction of this area A
Yes, direction of the A.
in the way of the lines. If this is perpendicular, so all the lines will passing through that, and the angle is, what we can say, 0, not tilted to any angle. So electric
Yes.
flux is a maximum. So electric flux is EA. E is the intensity, the value of the electric field, and A is the
Field
area of this perpendicular
area
electric
of the
field.
perpendicular region.
Yes. So electric flux is EA. Now this is the case when flux is 0. Why it is 0?
Yes.
Look at the figure.
Well,
Why?
because it's passing through. It's going in the same direction as the electric field lines,
Now it is
and
placed
they don't
parallel.
intercept in
Parallel.
between the lines.
No line is passing.
Yes, placed parallel. It's
So
placed
parallel in
parallel to the electric.
lines. So lines are passing without penetrating, because this is, so here the electric flux is 0 on this A. This
Yes.
rectangular area, there is no flux. So that's why this is just about the position and the strength of the electric field. So
Field.
perpendicular area is the greater, the flux is greater, And when you are putting the area 0, just placing it parallel to the electric field lines, so you will get the electric flux minimum. That is the minimum value is 0, and maximum value is the product of the area and the strength of the electric field lines. So this is the diagram
Yes.
which is explaining in detail the pictorial views of all those discussions.
Yes.
Now look at this. When we have
This
slightly tilted it to an angle
tilted the
theta.
cause
So E,
theta.
the lines are
Electric
those.
field. Yes,
So
and then
this is the angle theta, and we will have to resolve
cos.
theta into two parts. This is
Yes.
the cosine theta, and this is sine theta. We have resolved this.
Sine theta.
We have resolved already in the chapter one. The
Yes.
what we were talking about, the components, algebraic components, the rectangular
Yes.
components of a vector.
Components.
So
Vector.
only the cos theta is coming into action, which is a parallel over
Yes.
here. So theta is there. So you can see the theta, and this is a line making this theta angle with this red line. So we are resolving it to two rectangular components. This is a cosine theta, and this part is sine theta. Total intensity of the electric line field line is E. So E cos theta, E sine theta. So the flux is E cos theta into the area of this rectangular area. So I think it's very much clear now. But
Yes,
how
it's clear.
visualize three cases? Once again, we can
Yes.
see the perpendicular cases when the flux
Perpendicular, parallel,
is maximum. This was the parallel case,
zero.
the minimum,
Flux is zero.
and when it has some tilt in
Tilt.
angle in the way of electric field. So here
Tilt.
we will have to take the cause of that angle. So we'll have to keep all these things in mind when we are solving the numerical questions or examples. So the angle,
Yes.
when the angle is given, so you will have to take only the cause of that angle. That will come into the calculation. The sign of that angle
Yes.
is useless. No use of that sign, only use the cosine. So let's see the example. Can we read this?
Calculate the electric flux through the rectangle of sides 5 centimeter and 10 centimeter kept in the region of a uniform electric field 100 newtons per coulomb. The angle of theta is 60. Suppose theta becomes 0. What is the electric flux?
Yes, when theta becomes 0, the electric flux will be the 100 multiplied by 50.
Multiplied by
Where 50 is coming from the area. 5
8.
centimeter,
5.
5 into 10.
Yes.
5 into
Yes,
10
5 into 10 5 into 10 50 centimeters.
here.
50 times 100.
And when theta is 0, cos 0 is 1. So
1.
the value of E is also given. What is the value of E?
Yes.
What is the value of E?
Value of theta is 60 degrees.
What is the value of E? E is 100.
Electric 100. 100. 100.
E is 100. So what?
Yes, electric field is 100.
Yes, when the
100 times area.
theta
50.
is 60, so we will have to get the cos 60. Cos 60 is 0.5 or 1 by 2.
Yes.
So it's a mental calculation that 50
Yes.
into 50, 2500. That is the answer.
150.
I think
20.
that must be the answer, and maximum 0. So that is the 500. So
500.
uh, no 5000 because
No,
50,
yes, it will be 5,000 because we have 52 and then 5. 50 times
yes,
100, 5,000.
50 into 50, 2500.
Yes.
1000 is the maximum value, and 2500 is when the angle is taken as a 60. So cos 60 is 1 by 2.
Cos 60, 1 by 2.
Is zero point 0.5 or 1 by 2. This is the value of the cos 60. So
Yes.
what I was saying that
Solution.
like this.
Yes. Electric field, electric flux, then E is 100 times area 5 into 10, 50 times 10 raised to power minus 10 cos to value of cos, then cos theta is 0.25 and then theta is equals to 0, so we multiply theta
So
60,
actually, what we have
0.5.
seen, the centimeter is converted into
Yes,
meters.
meter.
So
When the root times 10, yes.
that's why we are getting the fractional values. So
Yes,
this 10 raised to power minus 4 or 0.5 or 0.2
0 0.5. Oh,
actual value or theta is 0. So I think it's very simple. You can solve so many of these types.
yes,
You will have to put the value
yes,
of theta and the electric field, and you will have to make it into meters because the area was given in centimeter. So he has converted each and every unit into the same unit. That is the meter, Newton meter.
Newton meter.
Electric flux.
Electric field. Electric flux is a non-uniform electric field in an arbitrarily shaped area. Suppose the electric field is not uniform and the area A is not flat. The entire area is divided into n small area segments, such that area element is almost flat and the electric field over each area element is considered to be uniform.
Yes. So this is the what we can say the application of integration in the sense then when we have the irregular area, so we'll have to divide it into smaller parts. Each smaller parts must be approximately the rectangular area. Then we'll have to take the summation. So sometimes
Yes.
we are calculating the electric flux of a body, which is in irregular shape, at a regular shape. So we will have to divide them into smaller pieces, delta, 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 n pieces. Look at this. So this is the irregular shape. You can see the blue area,
Yes.
electric
Yes.
for non-uniform electric field.
Line crossing through
So
and
this is
then
a blue area which is non-regular. So it is divided
non.
by delta A, and it can be divided into
Yes.
parts. So each delta A is a rectangular part which has the uniform area.
Yes.
So we will have to make use of the summation sigma is sigma starting from 1 to n, because we will have to divide this blue area in n rectangular parts, n rectangular components. So what?
The electric field for the entire area A is approximately written as pi e times area 1 times delta area plus
Delta A to
area
delta.
of, yes,
So
B
E
delta.
will remain the same. E is from 1 to I,
Yes.
and delta,
Yes.
so I is from 1 to n.
Delta will change
Yes.
and
So
then delta
delta
will
I is from 1 to n. So in this way, we will
end.
get the summation. By taking the limit delta ai tends to 0 for all I, the summation
Yes.
becomes
So it
equation,
becomes integration.
just like this.
Yes.
The total electric flux for the entire area
For
is
the
given.
entire area is given phi e times integration
Yes.
electric fields times d into area.
Delta D. A,
Delta. Acha, delta into area.
so this is the
It is
integration.
integration.
So we are operating with respect to delta A. When we are putting the
Yes.
limit that delta tends to 0, so it's becoming very, very small. Now we will, that's why this formula I have used in the law. If you can recall, or if you can see all those slides. So this was one of the formula when we were talking about the gases law.
Yes.
So just recheck in your own time. That was the formula with the sign of integration.
Sign of
Next
integration.
point is it is clear. Please read
It
this.
is clear that the electric flux for a given charge depends on both the electric field pattern on the surface area and orientation of the surface with respect to the electric.
Yes. So these are the two depending factors: the electric flux and the area, which is the pattern, surface, orientation, how much the angle is there with respect to the electric field. Next, please read this.
Field for closed surfaces. Suppose a closed surface is present in the region of a non-uniform electric field. The total electric flux over this closed area is written as summation phi e into integration electric field times delta area. The total electric flux over a closed surface can be negative, positive, or zero.
Yes. So we know that it can be zero or it can be negative or positive.
Yes. Electric field over a closed surface.
So this is a pictorial view. We can visualize the next is that we are dividing over here.
Dividing, yes.
So it is negative when theta is greater, less than or greater than pi by 2, and this is actually greater than pi by 2, 90 degrees. Now the angle is increasing, increasing, increasing. So
Yes.
theta, here the theta is greater than 90. Here this is coming closer, closer and closer. So it's becoming theta, theta is over here, that is
Yes.
less than, it's a sign is less than. So it's a slight correction. Now let me correct it. This is actually the less than. This is the less than. Oh, can you see this? How theta
Okay.
is less than pi
Yes,
by 2.
yes, I can see this. Less than pi by 2.
So this is greater. This is absolutely right. But there was
And then
some correction. So theta is less than pi by 2. Here we can see this theta.
yes,
So this theta is
yes,
less than 2.
pi
So
by 2.
theta is less than, what we can say, pi by 2, the 90 degree.
Pi by 2.
That is a coming
Like,
closer and closer. So in this way,
yes.
we will have to make use of that formula. So that's why dA. So we will have to divide this into a
Then,
smaller regions, smaller areas. Each and every
mhm.
area is divided into this.
And then find the,
Then we are putting the summation. We are adding this sign,
yes,
or we are just putting the sign of integration. This is also
integration,
for the summation. And when it is a
summation.
definite, so we will have to put the sign of this, and starting from 1 to n is the upper limit, 1 is the lower limit. But anyhow,
Lower limit.
we know all these formulas. Please, next, the last one.
In the figure, it is shown that in one area element, the angle between and is less than 90 degrees. Then the electric field is positive, and in another areal element, the angle between is greater than 90 degrees. Then the electric flux is negative. In general, the electric flux is negative if the electric field lines enter the closed surface, and positive if the electric field lines leave the closed surface.
Yes. So this is the rule you will have to keep, because they can ask that what is electric flux? Can electric flux
Yes,
be zero? Your answer must be yes. When they ask, can the electric flux be negative? So your answer
negative.
is yes, it can be negative. When it is negative, so this question is important. When it is
Yes.
negative, so you can read from here. The first point is
When a closed area, no, when it is in a closed area.
when it is negative,
No, the
when it,
electric field is negative when the electric field's lines are entered the closed area.
and when it is positive, electric flux is positive.
When they leave the closed area.
And one thing more is in the first point. So another way,
So the
in the first point,
areal element, the angle between is greater than 90, then the electric flux is negative. If it is less than 90 degrees, then it is positive.
yes. So this is also depending upon the angle. So they can ask,
Angles
theta is
and the,
n 90. So what is the nature of electric flux?
yes,
When angle is greater than 90, what is the nature of the flux?
negative
Yes, absolutely right. When it is less than 90,
when it is positive.
and when it is 90, equal to 90,
Equal.
zero. Cos 90 is zero. Electric flux
Oh,
is
yes. Yeah,
when
right.
it
Theta,
is zero. The angle, if the theta is zero, what is the value of electric flux?
zero.
Maximum. Cos zero is 1. So these are the
Okay.
question.
Oh, okay. ठीक है.
Cos
I
zero.
mixed up. I
So
mixed up.
you can ask then when the electric field flux is maximum. you must say when theta is 0. When the electric flux is 0,
0.
when theta is
Electric flux
90 degree. Theta is 90 degree. When
90
it is
degrees.
negative, no, it's all depending
Greater.
on the 0. So when
Yes.
theta is 0, it's a what we can say maximum when theta is 90.
Maximum.
The minimum 0 when theta
Minimum
is
0.
90.
Equal.
Greater than 90,
90 degrees is in
negative,
zeros.
less than 90, it's a positive. So all the four cases, either it is 0 or equal to 90 or less than
90.
or greater than 90. So
Greater than 90.
one way or the other they can ask about this. So these are all the conceptual questions. They may be in the objective type, or they may be in the short question that you will have to ask just to write or explain the angular situation of the electric flux. What is the what are the effects of the angle on the electric flux? So you will have to uh, discuss all these four cases very briefly. So this will become the short question about this. So now it's one thing. The last thing is that I would like to say that you must go through the Gauss's last statements, his explanation, and put this
Okay.
all together with that, because these are very much they have the correlevancy with each other. They are very much relevant
Okay.
to each other. So in one way or the other, so they may ask that state and explain the Gauss's law and
Yes.
describe the electric flux in the light of Gauss's law. So these are just mixing together. So just keep the track of these two very important lessons. They are interconnected,
Electrical flux and
and the
electric flux.
conceptual question may be coming from these two lessons. So intentionally I have divided
Okay.
two parts just to for the easy understanding. But this is the one topic, the electric flux and the Gauss's law of electric flux. So it's all about
Okay.
that. Okay. Allow this and just keep all them in
Allah
the
Hafiz.
and keep them notes and write down the important things which are lying in between the.
Okay.
So keep on making the sticky notes or whatsoever the you are making.
Yes.
Okay, Allah Hafiz. So tomorrow
Thank
we
you, Allah Hafiz.
3 p.m.
Yes.
Tomorrow
3.
Friday.
Okay.
Friday. Okay, Allah Hafiz. So it's end.
Allah Hafiz.
Allah Hafiz.